we shall begin our video presentation for geometric sequence. In this video, we shall define a geometric sequence. We shall show how to compute for the sum of the first n terms of a geometric sequence, and guess what? We will prove that sum. So a geometric sequence, also called a geometric progression, is a sequence in which the term after the first is obtained by multiplying a fixed number r to the preceding term. So what's different about geometric sequence is you multiply, whereas in arithmetic sequence you add a common difference. Here you multiply by a common ratio. A sub 1 is the initial term, r is what we call the common ratio, and this is how we compute for the general term or for the nth term. A sub n is equal to the first term times r raised to n minus 1. Okay, so let us interpret that. Let us put that into action. Find the indicated term of a geometric sequence. This is your sequence, and we are told it's a geometric sequence. Find the 8th term. Okay, so the first term is 3. How do you get the common ratio? Well, you pick any pair of consecutive terms. It can be 3 and 6, 6 and 12, or 12 and 24. Then you just get the ratio. How do you write the ratio? It's the later term. So I chose 12 and 6. So it's the ratio of the later term to the earlier terms. Okay, 12 over 6 is 2. It's the same with 24 and 12. 24 over 12 is also 2. So all the ratios must be the same. The same with arithmetic sequence. The difference between consecutive terms is a constant. N is equal to 8. Okay, so what is the 8th term? So a sub 1 times r raised to n minus 1. So 3 times 2 raised to 8 minus 1. That's 7. And you do the math, okay? I will leave it to you to do the math. It's 384. Another one. 1/4, negative 1/2, 1, negative 2. Can you guess what's the next term? So the next term is 4, negative 8. Find the 12th term. Again, the first term is 1/4. To know or to see the common ratio, you pick any pair of consecutive terms. Okay? It can be negative 1/2 and 1/4, but I am choosing negative 2 and 1. So how do you produce the ratio? So it's the ratio of the later term, negative 2, to the earlier term, it's 1. So in this case, it's negative 2. You can try it also with 1 and negative 1/2. So 1 over negative 1/2, that's also negative 2. So the ratio must be common, it's constant. And the 12th term, okay, you do that. That's 1/4 times negative 2 raised to 11 is negative 512. You do the math, you verify it yourself. Theorem 2.3, the sum of a geometric sequence. Just like with arithmetic sequence, we have a formula to compute the sum of the first n terms. So given a geometric sequence, the sum of the first n terms is given by this. So we need the first term, the common ratio, the number of terms, and of course, r cannot be equal to 1. What shall we do? Just like what we did with arithmetic sequence, we will prove this. Again, our lessons in Precalculus will have a part on mathematical induction. That part of Precal is all about proving. So we are already warming up for mathematical induction. So suppose we have a geometric sequence. Let us show that this is the sum of the first n terms. You begin the proof by writing the word proof. So the sum, Sn, is simply the sum of each of these terms. A sub 1, this is the first term, the second, the third, and this is the nth term. We add them all, that's the sum of the first n terms. I will multiply r to this sum. Why did I do that? You would know. You will know. When the proof is done, you will know. Okay, so multiplying r to the sum is the same as multiplying r to this sum. We will apply the distributive property of multiplication over addition. So r times a sub 1 is this. R times the second term is this one, loss of exponent. Pay attention to your loss of exponent until you get to the last term. So r times the last term here. Okay, loss of exponents. You will add 1 here. It becomes r to the n. Let us get the difference of Sn minus r times Sn. Why did I do that? You will find the answer when the proof is done. Okay, so that is the same as this, because this stands for Sn, minus this. This stands for r times Sn. And look at what's going to happen. Okay? Why is that so? All of a sudden, many terms vanished. Why? Because a sub 1r minus a sub 1r here, that's 0. Okay? Okay, look at that. A sub 1r, a sub 1r, and then minus. It's the same with this one. This is the third term. The third term minus the second term here is going to be 0. So they will vanish. All of that will vanish up to the last term here. And minus this one, so that's going to be 0, and what will be left is a sub 1 minus a sub 1 times r raised to n. So that is why we had this much simpler expression now. S sub n is a common factor. The same with a sub 1. We can factor them out. This is what happens. And we divide both sides by 1 minus r. Divide both sides by 1 minus r. And this is what we've got.